First one, it's about a tangent graph. And the tangent graph, quite honestly, is one of the toughest ones that they talk about. So here, I want to give you a little background here. You'll notice how they have this thing set up kind of like a regular equation. If this was a regular equation, say cosine or sine, this number in front would be the amplitude. Well, the thing is, what happens is that because there is no upper limit or down limit, this thing goes forever up and forever down. And what happens is it has asymptotes. It has places where the graph's not going to happen. In this case, it appears like it's not going to happen here, and it looks like it's not going to happen here. And it's going to repeat over and over again. So clearly they've done stuff to this, okay? We've got to figure out what. So let's start by thinking about what it looks like when we haven't done anything to it at all. You good? If I haven't done anything to it at all, then what's going to happen is that, well, here, you know what? Let's see if we can take a look at one. If we haven't done anything to it at all, it's gonna, let me set this up real quick. Radians, we'll go 0.25 pi.
Mr. Cross?
Yeah.
Is this meeting recorded?
Pardon me?
Is this meeting recorded?
Yeah.
Okay.
And let's go to, say, 1.5 pi. And if I were to graph this, tan x, whoops. How does ours look? Ours goes by radians and it goes up to 7/4 pi. Seven divided by 4 pi. And we're going to go by 0.25 pi. All right, so you'll notice that what happens is that there's going to be a line here that goes straight up and down where this graph is not going to touch. And it's also going to go here. Typically, this is going to be 180 degrees or 1 pi. Do you see how this goes from negative pi over 2 to positive pi over 2? This is what's happened before we've done anything to it. Now there's a couple major points. Number one, you'll notice here this middle point, okay, where it kind of changes. It's the middle of this long stretch here. It should be at 0. And then let's take a look at what they have. In the question, if you take a look at this graph right here, you should see that what's happened is that this point, this middle point, is actually up here now. Okay? Now, you'll also, and this point, if we hadn't done anything to it, it would be over here. So clearly it's moved up by 1, and it is moved over to the right by pi 1/4 pi. So that's going to go here. We're going to say that it moved 1/4 pi. And then the c at the end, it's going to be where it moved up by 1. And see this a, this is different. In a regular, what's going to happen is when I go from this point to this point, when I go over 1, it's going to go up 1. Instead, do you notice how I go over 1 and it goes up 2? And this goes down and over 2? What's happened is it's changed the stretch, okay? So normally it would go up 1 and over 1. It's going up 1 and over 2. I mean, up 2 and over 1. That's this number in the front. And like I said, I mean, this is a tough one. I mean, just know that when it's with the x's, it's going to move left or right. You're looking for this center point. It should be here at the 0 if it's a tangent graph. It's not going to get super, super complicated. If you can do this part right here, you can see that it moved over and it moved up. And that's going to give you these two right here. And then, like I said, this other thing, think about like an absolute value graph. If it's a straight absolute value, the slopes of the lines go up 1 over 1, up 1 over 1. If I put a 2 in front of it, well, what's going to happen is the slope of the lines is going to be 2. Well, that's what's happened here. This goes up 2 and over 1, and it goes down 2 and over 1, and that's what this is going to represent instead of an amplitude. So anyway, if you take a look, they say that A should be 2. They say that this B, this thing right here, we shifted over to the right is pi over 4, and then it went up 1. And like I said, this point right here, this this middle of the graph, that's, if I know that it used to be here, I can definitely get these two pretty easily. All you got to remember is that this makes it move left or right, and this makes it move up or down. Any questions about that?
Do we have to memorize the numbers from the tan graph, the original number, or no?
No, well, it's a good idea. You have to know the general pattern. What you should know is that it generally is going to go to negative 90 to positive 90, and it's going to be normally the cycle is going to be 180 degrees long. You should know that, and you should know that, like I said, that this point here is going to be here at 0. And like I said, I'll be honest with you, this is the first tangent graph question that I've ever seen them ask. And I haven't looked at every single test. Most of the time, if they ask a question, it involves a sine or a cosine. As a matter of fact, last year, quite honestly, I didn't even teach them that much because we were doing remote and everything. I didn't even teach them hardly anything about tangent graphs. We pretty much ignored it. And so then this actually was on the test. This came from their test. So then I felt pretty stupid. But the truth is that, like I said, it doesn't happen very often. This is really kind of rare. It's really the first time. Doesn't mean it'll never happen again, but I'm just saying. Most of the time when I see questions about these trig graphs, it's going to involve sine and cosine. And you should know that their general patterns are and what their normal cycle is and that kind of thing. Now take a look at this one. This was the proof one. And these proofs and the solving ones are really common. I see this, as a matter of fact, you'll see, I go through and I've taken some questions. There's 3 versions of the test they gave last year. And you're going to see there's a question like this almost on every test. And then I took some questions from the year before that. Like I said, this is very, very, very common. Now, if you're terrible at proofs, then maybe you don't worry about the proving part because you don't need to prove this to solve it. The solving is actually worth more points, and you don't want to get stuck down a rabbit hole. As a matter of fact, if it were me and I knew I wasn't awesome at doing proofs, I might go ahead and solve this because I have everything I need to know before solving it, and then come back to it later. Because keep in mind, on the real test, there'll be there'll be lines after the proof and there'll be lines after this. You could go ahead and do the solving, and then if you have time at the end of the test and you want to play around with the proof, well, then you can. And like I said, maybe you're great at proofs, maybe you feel good about proofs, and so then go ahead and do it. But anyway, what I want you to do is take a look at this and see what you think you can do. How can I prove that this is this? Take a minute and just try doing it, and then we'll talk about it. Anyone got an idea about what we want to do? Start it. I've written the trig identities that you're going to need to know, and keep in mind this one is on your formula sheet, and this one is on your formula sheet. But what happens is these other ones get derived from this, and they're really important to remember also. Anyone got an idea about what we can do? Giovanni, what do you think we could do?
So what? So since it's tan, so since there's a tan on the right side, I think that you should make 1 minus sine squared theta to cosine squared theta.
That's a good idea. All right, so this definitely can become that, right? That could be equal to what? Cosine squared?
Yeah, cosine squared theta.
We definitely can do that. Now, what can we do with this?
You could factor it out. You can make it 1 minus sine theta and 1 plus sine theta, like factor it out.
Well, see, the problem with this is that they don't both divide by sine. It's not difference of two squares. We can't do that. But can I replace this sine squared with anything?
You could replace it with 1 minus cosine squared theta, but I don't know how that would help you out.
So then what about this? Can I replace the 1 with anything? What's 1 equal to?
Oh, sine squared theta plus cosine squared theta.
All right, so let's try that. What if we did that? So what if I said cosine squared plus sine squared minus 2 sine squared? So now what can I do? What's sine squared minus 2 sine squared?
-1 sine squared theta.
So if I do that, this stays the same. This becomes -1 sine or minus sine squared. And then what am I dividing by?
Cosine squared theta.
Which basically means both of these things get divided by cosine squared, right? What's
Yeah.
cosine squared divided by cosine squared?
1.
What's negative sine squared divided by cosine squared?
-tan squared theta.
That's what they wanted. Now, there could be some other things you could do. And here's what I am going to tell you. In most of the proofs, they don't go super, super long. So if you find yourself writing a whole ton of stuff, then probably you've missed something or you've gone down a rabbit hole and it's a good idea to stop. The other possibility would be replace this with 1 minus cosine squared. If I replace this with 1 minus cosine squared, quite honestly, I'm not sure what you would get or how that would work. But anyway, I mean, that's the only thing I can think of right off the top of my head. Then, keep in mind, what we're trying to do is we're trying to replace with something. In this case, I replace the 1 with cosine squared plus sine squared. So that's going to be part A. Now, then what happens is after these proofs, they talk to you about solving. Now, here's the thing. You don't have to start all over again. I know that this is equal to this. So now all I got to do is rewrite this and make my new equation is going to be 1 minus tan squared theta is going to be equal to what? 2 tan to the 4th. All right, so do me a favor, take a try at this. Try writing it down and see what you think you might do. Alexa, what do you think you might do about this? Kayla, what do you think you might do about this?
Could you factor the 2 tan to the 4th?
What do you mean? What would that look like?
Could it be like tan to the 4th times tan to the 4th?
I get you. All right. So, and yeah, I guess you technically could, but then you have to ask yourself how that would help you. So here's what I want you to think of. Do you remember when we solved quadratics? And then we solved quadratics, and then sometimes we solved things that looked like a quadratic, but they didn't have the same powers. If I move everything over to this other side, it's going to say 2 tan to the 4th theta, and then what?
Plus tan squared theta
And then what?
minus 1.
Equals 0. All right. Now, there's a couple different ways to go about doing this, but what you can do is that if I rewrote this and I said that h is equal to tan squared, that means that h squared would be tan to the fourth. And so now what I can do is I can write this equation. So this is going to be h squared, actually 2h squared. This is going to be plus h, and then minus 1 is equal to 0. And see, now I've got a regular quadratic, and I can try to solve it, which you can use the quadratic formula and then use your calculator, or you can factor it. How would I do that? Do either one. Tell me what you get. What's h equal to?
1/2 and -1.
All right, and again, I just factored it. If I do that, then my answers are going to be the opposite of these two. It's going to be -1 or positive 1/2. Now here's the trick. These aren't my answers. These are what h is equal to. And what's h equal to? Tan squared. So now I'm going to replace what h is, and it's going to say this. All right, now what do I do?
Do you square root it?
Exactly. So what's going to happen is I'm going to square root this, and it's going to equal the square root of 1/2, right?
Yes.
What is it also going to equal?
Positive.
It's going to be plus or minus the square root of 1/2, right? So there's the plus one, and there's the minus one. Now tell me about this one. If I square root both sides, that means I have to take a square root of a negative number. Is that something we're allowed to do?
No.
No. And again, you remember from math too that you probably can, but in Cambridge, that's never going to happen. If you ever find yourself having to square root a negative number, at least at the AS level, then you can forget about it. That's not something we're going to do. So all I got to do now is what? How do I find this angle? How do I get this angle by itself?
You switch them?
I'm going to switch them. So remember when I do the inverse, the angle and the input and the output switch places. So now on the inside is going to be square root of 1/2, and on the outside is going to be the angle. And then here, when I do the inverse, this is going to be on the inside, and this is going to be on the outside. So now all you got to do is go to your calculator. What happens? Now, by the way, what are we talking about here? What's our unit of measure?
Degrees.
So you got to make sure you're set for degrees. And then tell me what you get when you do this.
I got 35.26.
All right, so we got 35.26 degrees, right?
Yes.
And what happens when you do this one? So now just use the arrow key and go back and put a negative sign in front of it and tell me what you get.
Negative 35.26.
Negative 35.26. All right, now, where do my answers have to be?
Between 0 and 180.
All right, so am I okay with the 35?
Yes.
Now keep in mind, I can find more answers when I'm talking about tangent by adding or subtracting 180. Do I want to do that with the 35?
No.
No, because if I do that, then I'm out of the range, right? Now, This is another answer, but is it acceptable?
No.
However, can I add 180 to it?
Yes.
What happens when I add 180 to it? What do I get?
144.74.
Degrees. Those are our answers. All right. Now, the funny thing is that this proof, if you're good at it, it's 2 points and it really doesn't take that long. But don't get me wrong. I mean, like, I'm not saying, I mean, when the first time I went to go do this, my first guess was not to replace that with a 1. My first guess was to replace this with an, like, it just got super complicated and I had to start all over again. So, but, you know, this is more work, but it should be a little bit more straightforward and people should be more comfortable with it. Do you have any questions about what's going on with this? So then when you see the rubric, if you would have gotten here, do you see how they've got this? Definitely with the cosine squared. And what did they do? Cosine squared minus sine squared. Did we get that somewhere? Oh, yeah. So if you were to get to this spot right here, that's where the point. Okay? So, like, even if you just would have got this cosine squared, it really wouldn't have been enough. If you would have got here, you would have got 1 point. And then if you would have got the whole answer, then you would have got the other point. It only was worth 2. And again, that's another thing you've got to think about when you're talking about these test questions. For the proofs, you've got to get substantially way in. It's only worth 2 points. So you're going to have to get halfway in. Just doing something probably isn't going to be enough, depending. I mean, if it's only worth 2 points, then you're going to get about halfway there and then you're going to finish it. And then here you can see they have the 135, or no, 35.3 and the 147. And you can see, I mean, there's only 2 method points. One is to set it up as a quadratic, and then the other one is to solve it, and then clearly notice that we only can use the 1, but it had to be plus or minus. And you can see the common mistake here is to not do plus or minus. All right. Take a look at this one. I want you also to notice that in a lot of these, what happens is they're set up as fractions. A lot of times what's going to happen is that they're going to love to use these rules with fractions where we have to get a common denominator or something like that. So Edwin, what do you think you might want to do here?
You can find the common denominator.
Yeah, what do you think that's going to be?
Uh, 1 minus sine square x.
What we're going to do is we're going to, well, what is it going to be? It's going to be this times this, right?
Yeah.
All right, so let's take a look at that. If I were to do that, what do I multiply this one by? 1 plus or 1 minus?
1 plus.
So then the top has to get multiplied by 1 plus. So what I'm going to do is I'm just going to write 1 plus sine x, but then it's going to be squared. Right? You with me on that?
Yeah.
And then what's going to happen is the second one. If I multiply this by something, what's it going to be multiplied by?
1 minus.
And so I'm going to do that the same thing to the top here in the numerator, and that's going to be minus 1 minus sine x, and that's going to get squared. Now, then what's going to happen is it's all going to be over what?
1 minus sine x times 1 plus sine x.
Okay, now, what do you think you might want to do now?
Multiply the denominators.
What do you mean? What happens if you multiply them? You mean these two guys?
Yeah.
What do you get when you multiply 1 minus sine x times 1 plus sine x?
You get sine x squared minus 1.
You would get 1, and then you would get sine, and then you would get negative sine, and then you would get sine squared. You would get 1 minus sine squared. What's 1 minus sine squared equal to?
Cosine squared.
Which you'll notice we're trying to get a cosine on the bottom. So I like that. Okay? Now I'm going to hold on here because I don't want to rewrite this. What can I do with this? What happens if I just squared it? What do I get if I just square this? What's 1 times 1?
1
And then what's 1 times sine?
sine,
So double it. What do you get?
2 sine,
And then square the last one. What's that going to be?
plus sine squared.
Now do the same thing. Now here you have to be careful because I got the minus sign. So now all of this stuff has to get subtracted. What's this squared? What's 1 squared?
It would be 1 minus 2 sine x plus sine squared.
And if I distribute this negative sign, then what's going to happen?
It would be minus 1 plus 2 sine x minus sine squared x.
So let's get rid of that. Now, this is one thing. This is one thing. This is another thing. This is all the numerator. You with me on that? So what's 1 minus 1?
0.
All right, they're gone. What's 2 sine x plus 2 sine x?
4 sine x.
All right, I guess we got to write that one down. And then what's sine x, or sine squared minus sine squared?
0.
So all out of all that stuff, now all I've got is a 4 sine x. You with me on that?
Yes.
Now that's my numerator. And we said, what's 1 minus sine squared equal to?
Cosine squared.
So let's put that over here. As a matter of fact, now this one I'm going to separate. I'm going to make it cosine x times cosine x. Because that's still cosine squared, right?
Mm-hmm.
Now, what do I trying to achieve here?
You're trying to keep one cosine in the denominator and then
So tell me, what's this equal to?
410x.
410x, right?
Yeah.
That's equal to 410x. And then I'm
But
going to
you would-
multiply it times what? 1
1.
over cosine, right?
Yeah.
It's going to be 410x over cosine x. What do you think about that one, huh? That's lots of fun. Any questions about that? I like this better because it's a little bit more straightforward, and it's a little more typical of what kind of things you have to do. If you get one where you got the common denominator And then you do this, and then, like I said, I mean, at some point you just got to do the math. But you'll notice how we've got to separate. We got to do replace. Anyway, let's take a look at the next part. Now I'm going to solve it. I got to tell you, this upset me today. So this 4 tan x over cosine x is equal to 8 tan x. So what do you think we should do? Kayla, what do you think?
Could you separate the tans to sine over cosine again?
I could, but how's that going to help me? Now keep in mind, this is an equation, right?
Yeah.
So at the end of the day, what I want to end up with is I want to end up with one variable, if I can help it. Now, what I tried to do was multiply both sides by cosine x. And then I divided both sides by 8 tan x. What's 4 tan x divided by 8 tan x? 4 tan x divided by 8 tan x. What's tan x divided by tan x? What's anything? It's 1. What's 4 divided by 8?
1/2.
So what happened was, by doing that, I had a cosine over here, and then I had a 1/2 over here, and I felt very happy with myself. You with me on that?
Yeah.
All right. Now, the problem is, evidently, and I guess, I haven't really had this come up in any of the Cambridge problems, but here we are. It did come up. Evidently, you want to try to avoid dividing both sides by something. Now, don't get me wrong. I know we do it sometimes, but what happens is that when you do, you run the risk of missing one of the answers. Now, here's what I'm going to show you, and I'm not sure it's worth the effort, but what they suggest, what they did is they went like this. Actually, I had to look it up. I had to look up on YouTube because I could not figure out why the rubric had another answer, and I couldn't figure out how to get it. All right, so anyway, when I did it, I did this. Cosine x is equal to this, which means cosine x is equal to 1/2, which that shouldn't be a big deal to solve. I'm going to switch these, and I'm going to put a 1/2 in here, and it's going to equal x, right? And I'm going to get an answer. That's what I did. What they say to do is go like this: 4 tan x over cosine minus 8 tan x and make it equal to 0. And then what they are saying to do is factor out this tan x. If I factor out the tan x, 4 tan x as a matter of fact, then what's going to happen is this is going to be a 1 over cosine x. And then this divided by 4 tan x is going to be 2. So this is minus 2. Now, when they do it this way, I have 4 tan x equals 0. And I have this where if I add 2, we'll just do it. If I made this equal to 0 and I added 2, then what's going to happen is I multiply both sides by cosine and then divide by 2. I get cosine x is equal to 1/2, which is what I got. However, I didn't get this. All right? And so if I go to solve this, We'll try it. What happens when you put a 0 in there? We're set for radians. Inverse tan of 0 is going to be 0. What happens is that one of the answers is 0, and the other answer is, what is cosine? I didn't even finish it when I did this earlier. What's inverse cosine of 1/2? 1/3 pi? Pi over 3? And then you take a look, they've got a pretty narrow range here between 0 and 1/2. So you remember the cosine thing, I would plot this one, 1/3 or 1/3 pi. And because it's cosine, then I would go over this axis. But clearly, that's going to be a much bigger number than 1/2 pi. And it's not, and it's either going to be negative or it's going to be much bigger than 1/2 pi. So the only answer is this one that we found, where it's pi over 3. And then there's this one here. So, I mean, quite honestly, this is a lot of work. This was worth 3 points. I don't know that I'd worry tremendously about it. I would, because if you go ahead and do what I said here, you see with this proof was worth 4 points. So you could, I mean, and again, I'm going to kind of weigh this kind of thing out. I could do a little bit and then still get the proof. And still maybe get some method points. Notice how you can get a method point just for using a common denominator. And then multiplying the common denominators and getting the tops. I could get 2 points just from doing those two process things. And then here, like I said, it's possible that you could get a couple points on this one, even if you weren't that great at it. And then here, you would get 1 point for getting the cosine x 1/2, and then that answer, that's the second point. And then the third point would have been this x equals 0, which, like I said, I had to look it up, so I wouldn't have got it. But anyway, any questions about that one? All right. Now this one's a little bit different. Try this. It's worded a little bit differently, but we're still doing the same thing. Basically, what they're wanting us to do is they're wanting us to change this into this. So for this part, don't worry about the equals k. You just worry about making this look like that. So Kayla, what do you think?
The tan x's could be a 1.
Oh, okay. Because of these two, you mean?
Yes.
Now keep in mind, I only can do that if these are factors, if these guys are getting multiplied together. So, like, keep in mind what you're doing is dividing, right? If I divide that away and change it into a 1, well, then this sine x doesn't get divided by the tan x. The only time you can do something like that, like cancel, is going to be 2. And I can see why it's so tempting, because it's staring you right in the face, isn't it? And you feel like you should just go draw a line straight through it. And that would give you a 1 too, right?
Yeah.
So if I take that away from you, then what's the only other thing you can think of? What can I replace tan with?
Cosine over sine.
Reverse that. Say it one more time.
Sine over cosine.
Yeah, think of tisk. I don't know why. Well, I don't know why I remember it that way. Tisk is tangent is equal to sine over cosine. So if I did that, it would look like this. And then plus, and since I'm doing this, I'm going to go ahead and make this a fraction. You with me on that? And then what's going to happen in my denominator? It's going to be the same thing, right?
Yes.
Now again, as I'm sitting here doing this, I'm not really sure how this is helping. All I can tell you is that when I went to go do this the first time, I couldn't think of anything else to do. Now, look at the numerator. I'm adding 2 fractions. What do I need in order to add 2 fractions?
A common denominator.
And what would it be in this case?
Cosine.
So if I make this a cosine x, what do I got to do to this guy, top guy?
Multiply it by cosine.
Cosine x, yes?
Yes.
All right, so now this is going to be sine x plus sine x cosine x. You with me on that?
Yeah.
And then what's it going to be divided by?
Cosine x.
All right, now, using this logic here, we're going to end up with something very similar on the bottom, right?
Yeah.
What are we going to end up with?
Sine x minus sine x times cosine x over cosine x.
Exactly. Now, do you notice how they're both being divided by cosine?
Yeah.
If I, and again, think about this. This is my big dividing line, right? Instead of dividing by a fraction, what can I do instead?
Multiply by the reciprocal.
Exactly. Now, you wouldn't have to do that, but most of you know this better, this multiply by the reciprocal. Do you see how I've got 2 fractions and they're both divided by the same thing? You could just cancel out this bottom, but let me show you how that works. If I go like this and multiply by the reciprocal, then this looks like this. So now that's not down there anymore. And then what happens to these cosine x's? They're gone, right? So then what do I have? That on top and that on the bottom. Yes?
Yes.
All right. Now what do you think I can do? Do you notice how both of these have a sign in them?
Yeah.
Could I factor out the sign?
Yeah.
So let's write this. Again, now keep in mind, because I'm getting kind of discombobulated here, but I'm working on this right now. So I'm going to write sine x. Now I'm going to divide that whole thing by sine x. What's sine x divided by sine x?
1.
1. And then what's sine x cosine x divided by sine x?
Cosine.
Cosine x, yes. And it's plus. All right, now if I do the same thing for this bottom, what's this divided by sine x?
1.
And then what's this divided by sine x?
Negative 1.
Well, negative what? Because it's negative what? Yeah, negative cosine, right? So now what happens? Sine x. See, now here's the thing. Now I can cancel these out. Do you notice how it's sine x times something and sine x times something? Now I can cancel these out. I can't cancel out these ones and I can't cancel out these cosines because they're not factors. They're being added together. I have to leave them the way they are. And I would want to anyway because that's what they said I was supposed to end up with. But But this, when I have two things multiplied together, I can only cancel out factors. Does that make sense?
Yes.
All right, so then we get down with that. There's a lot of work for 2 points. But the thing is, if you think about it, it really wasn't that hard of work. We had created these fractions, we created a common denominator, and then what happened was we factored it. We divided, multiplied, and then we factored both of them. And that's how we get this. Any questions about that? Okay, so now in part 2, they say they want us to express cosine in terms of x. So mind you, these are gone. Here, let's go and erase it. Erase it. And this equals k. Now, what they want me to do is they want me to express cosine in terms of k. So what does that mean? Giovanni, what does that mean? What's the answer going to look like?
I don't really know.
When they say to express cosine in terms of k, what they basically want is cosine by itself and then k's on the other side. Does that make sense?
Yeah.
All right. Now, let's try. What would I do here? How can I get rid of this fraction?
You get multiplied by 1 minus cosine x.
Yeah, and I'm going to go up here. So if I do that, this is going to be 1 plus cosine x, because that part didn't change, and it's going to equal k times 1 minus cosine x. You with me on that?
Yeah.
And then when I distribute this k, what am I going to get?
You'll get k minus k cosine x.
Yeah. Now keep in mind, my whole job here is to get the cosine by itself. All right, so what can I do?
You can subtract by 1.
I can subtract, what do you, get this 1 out of here?
Mm-hmm.
All right, I get the 1 out of there. What else can I do? I might as well get the cosines on the same side, don't you agree?
Yeah.
So even though this has got a k on there, I'm not thrilled about that, but it's got a cosine too. So if I add k cosine x to both sides, you with me on this?
Mm-hmm.
Now, what's 1 minus 1? That's 0, right?
Right.
Now this is going to be cosine x plus k cosine x, yeah?
Mm-hmm.
And then it's going to equal, so now the k cosine x is gone, and so all I end up with is k minus 1, yeah?
Yeah.
All right, now keep in mind, my job is to get the cosine by itself. You notice how there's two terms here when they both have a cosine in them?
Mm-hmm.
If I factor out the cosine, what's cosine x divided by cosine x?
1.
And then what's k cosine x divided by cosine x?
K.
Now, how do I get the cosine x by itself?
You'll divide by 1 plus k by each side.
And so what's going to happen is cosine x is going to equal, and I'm going to just rewrite it so it looks the same, k plus 1. You with me on that?
Yeah.
Now, this is me expressing cosine x in terms of k. It equals cosine x, and it's got k's over here. Does that make sense?
Yeah, just like the wording, like, it
I
kind of
know.
confuses me.
Exactly. So whenever they say express something, that means basically they're saying get it by itself. And what they're saying is, hey, I know there's going to be a bunch of k's laying around. That's okay.
Yeah.
All right. So the last thing we got to do then is got to solve this, right? Now solve this equal 4. Now, if it's me, I'm going to go up here and I'm going to do this equals 4. All right? Because we turned this into that, yes?
Yeah.
So now, if I was solving this and it equals 4, what would I do?
You'll want to get rid of the fraction.
So I'd probably multiply both sides by 1 minus cosine, yes?
Mm-hmm.
That's going to give me 1 plus cosine x is equal to 4 times 1 minus cosine x. Yeah? Then what am I going to do?
You'll distribute the 4.
Yeah, and I get 1 plus cosine x is equal to 4 minus 4 cosine x. And then what am I going to do? If I add 4 cosine to both sides, what's that going to be?
You'll get 1 plus 5 cosine x equals 4.
And then if I subtract 1 on both sides, it's going to be 4 minus 1, right?
Mm-hmm.
So this is, if I add 4 cosine x, that's going to give me 5 cosine x, yes? And
Mm-hmm.
if I subtract 1, it's going to equal 3, yeah?
Mm-hmm.
So then all I got to do is get this cosine x by itself. What's that going to be?
Cosine x equals 3/5.
Yeah, exactly. I'm going to come down here. So cosine x is equal to 3/5. And then how do I solve that?
Use the inverse of cosine.
So we're going to replace them. 3/5 equals x. What kind of, what am I talking about here? Notice how I'm in radians.
Mm-hmm.
So what do you get?
I got I got 0.927.
0.927. Okay, now how's that fit within the range we got to be here? This is good, right? Is that it's positive, and clearly it's less than pi, yes?
Mm-hmm.
And then if I do this, 0.9, that's gonna be up there. I'm gonna go down here. Now again, it can be negative pi, but that's much big. This is much bigger than negative pi, isn't it?
Yeah.
So then what's this gonna be? What about this one? Huh. Wonder if that's one of the answers. Nope, that's the only one. What's the 0.927? Now, what happens is a lot of times in these cases is that they'll ignore answers that are outside the range, but they won't. But you get it wrong if you have extra answers that are in the range. All right. So that's what I got for. I mean, we're out of time for that. It's 4:00. I could open it up for questions. You have any other kind of questions, or do you want to do more trig stuff?
Can we go over that sheet
Yeah,
that you
what
gave us
sheet?
today?
Yeah, you want can if you want. Which one you want to look at? Hang on, let me find it.
It's the probability practice.
Let's see here. Gonna find it. Which one's you interested in?
Which one did you say to not do?
Good
Because you
question.
said one of the. I forgot which one.
Let's see if we can find it. All right, so to answer your question, which one not to do? This one here, number 4. It involves permutations, which you guys haven't talked about yet. So that's why I said don't worry about it. What other question do you have?
Well, in that case, can you go over number 7?
What's number 7 saying?
It's about the swimmers.
All right, so what do we know?
I don't know if this is right, but I try to fill in some information
Okay.
on the diagram. So I put 0.45 for the beginners where it says females.
Okay, that's a good idea. How do you know that?
I did 1 minus 0.55.
Right. Let's make this a little bigger.
And then for advanced swimmers, I did 1 minus 0.7.
All
And
right,
I
so
got
we'll make this 0.45. And then we're making this what?
0.3.
Okay, good. Now, what else can we add?
The only other thing it says is that the probability of being an advanced swimmer is the same as the probability of being a beginner.
Okay, that's good to know. What can I add to this thing here? If this is X, what does this got to be? Females.
1 minus X.
Yep. I don't know what X is, but I do know that whatever it is, if I take 1 away and then subtract 1 from it, that'll be the what females. Isn't that true?
Yeah.
All right, so let's talk about this. It says that what's equal to what? Advanced?
Yeah.
Advanced is equal to beginners? So let's try that. How would I write down the probability for the advanced?
Uh, we well, it's for a randomly chosen member. So, what do you do?
How would I if there was a number here, how would I do it?
Well, I would multiply 1 minus X times 0.55 for advanced.
1 minus X times 0.55. Okay. Now that's one way to get advanced swimmers. What's another way to get advanced swimmers?
X times 0.3.
Now, that represents the only 2 ways I can get advanced swimmers. Isn't that true?
Yeah.
Now, what does it say? It says it's got to be equal to what?
The probability of it being a beginner.
All right. Well, same thing. How would I figure out the probability of being a beginner?
You would do 1 minus X times 0.45 plus X times 0.7.
Right.
And
Now,
then we would just add for X.
it's not the prettiest equation in the world, but you do notice that I only have one variable, right?
Yeah.
I mean, yeah, there's some distribution here, and then there's going to be some combining here, and then there's some distribution here, and then combining. But then at some point, it's going to start getting smaller, and then all I got to do is get X by itself. Now, once I get X by itself, then I can fill in this and this, right?
Yeah.
Try it.
Yeah, I'm doing it right now. 0.25X.
Kayla, did you get this one already? Did you do this one in class?
No, but I found X.
Oh, what'd you get for X? Did you just do it just now?
Yes.
What'd you get for X?
0.2.
Edwin, what'd you get?
Yeah, I got 1/5.
Which is 0.2, right?
Yeah,
Now, if that's 0.2, what's this going to be up here?
that's gonna be 0.8.
All right. All right. Now, what's the second part of the question?
Given that a randomly chosen member is an advanced swimmer, find the probability that the member is male.
All right. So you notice the word given.
That's what
Okay.
we divide, right?
All right. So what's going to happen is I write it like this. The probability of what? Find the probability of what?
Of male.
Being male. Given what?
Is an advanced swimmer.
All right. So what's the probability of it being male given they're advanced? Now, what I'm going to do is I'm going to find the probability of both. What's the probability of both being male and an advanced swimmer? What's the probability of both? Now that I know this.
Wouldn't you multiply?
What am I going to multiply?
0.2
Times.
and 0.3.
Exactly. Okay. That's me. That's being a male and advanced. So that's going to be 0.2 times 0.3. You with me on that?
Yeah.
All right. Now I'm going to divide by the given. What's the probability of being advanced?
You would do 0.8 times 0.55 plus 0.2 times 0.3.
So 0.8 times 0.55 plus what?
Uh, uh, 0.2 times 0.3.
Exactly. When you're reading these questions, and number one, I mean, typically they like to put them towards the end, especially if it's a tree diagram. All right. But if you see the word given, then this is what we want to do.
So would it be 0.12?
Yeah, exactly.
So when you're given, so when it says given,
And see, sometimes what will happen is they'll say, find the probability that a member is male given that they're advanced. And other times they'll say, given that do you see how this time they put the given thing first? But
yeah.
whenever they give you two things, find a probability, but then there's some kind of requirement, given that they're advanced, then you know that this is what we're doing. Find the probability, and then there's some kind of criteria that narrows things down. It's going to reduce the probability.
So the given is, so the probability of the given is what you divide by, and the other probability is what you put in the numerator.
Well, like I said, think of it like this. If I write it like this, the way they, like that, and see, he knows how to put the given thing first. They're trying to throw you off, but I want the male, and then given that they're advanced. Take these two,
Because it's both, right?
yeah, it's the probability of both divided by the probability of the given. So all you got to do is find the situation where they were male and advanced. And that only happened one way. This times this.
And then,
Then you divide by the given. And almost certainly there's going to be more than one way for that to happen. Do you notice how the thing on top is part of what's on the bottom? But the same thing, I can't cancel it out because I've got to add them together first. But That's almost always going to be the way. There'll be 2 parts or 3 parts to the bottom, the given, and we're going to take one of them and it'll be in the top. But the way I remember it is, it's the probability of both divided by the probability of given. That makes sense?
Yeah.
All right.
So I know you said for number 6, don't do 4.
Yeah.
But how would you do number 3 where it says it's similar and like this time the given is after? So it says for number 6, find the probability that a randomly chosen student.
All right. So find the probability is not studying drama. Probability, and that means not studying drama. Complement. Okay. You with me on this?
Yeah, that means it's not
Okay.
drama.
Given what?
That the student is a girl.
Okay. So now what I got to do is I got to find the probability that they don't study drama and they're a girl. What's that probability?
So would it be 15 plus 12?
Out of how many?
Once
160. That's the probability of both. These guys are not studying drama and they're girls. Does that make sense?
Yeah.
Now, what am I going to divide by? The probability of being a girl. How many girls are there altogether?
There are 64 out of 160.
And see, again, do you notice how both of these are divided by 160?
Yeah, so it would just be 27 out of 64.
Exactly.
Oh, that makes sense. And like, so number 2, I got that they're not independent by using that formula of multiplying and then doing the probability of both.
Yeah.
And it's and.
Good.
And I got 39 over 200 is not equal to 1/4.
You got,
Oh,
well,
that's
so
right.
here, what are the, I can't remember the question. Determine whether the events, a randomly chosen student is a boy and the randomly chosen student is studying music are independent. Okay. So what's the probability of being a boy?
Let me see. 96 out of 160.
All right. Now, what's the probability of a student studying music?
52 out of 160.
All right. Now, what's the probability of a boy studying music? That means this means and. They're doing both. How many boys study music?
How many boys study music? 40 out of the 160.
Okay. Now, I got this from the table. You with me on that? Now, if I multiply 96 over 160, if I multiply the probability of B times the probability of M, if it equals 40 over 160, then they're independent. If it doesn't, then they're not. So if you multiply these two fractions and it equals anything but this.
I got 39 out of 200 does
Right.
not equal 40 or 160 or 1/4.
Not equal. Exactly. So, and again, if this was an
So that
official
means
test or
it's not
whatever, because you multiplied the probability of the boys times the probability of the music, and you did not get the probability of a boy studying music, they're not independent. If you would have gotten 40 over 160, then we would have said they're independent. That makes sense?
Yeah. And for the first part where it says find the probability that a random student is studying music, you would just do 24 plus 15, which is 39, add on 60. Wait, no, sorry, 40.
If they
40
are
over,
studying
wait, no,
music.
sorry, 40 plus 12. So 52 out of 160, right?
Yeah. Because
It
again,
would be
notice the
everything
wording. It's not saying boy and it's not saying girl. It's saying student.
Yeah, so it can be boy or a girl.
Right.
Okay. That makes sense. So is there ever a time where you don't multiply, you just add? Is that like the dependent type of probability?
No, you add when you're willing to accept more than one thing. What's the probability of a boy studying art or music? Now, if I didn't have this table, I would do 24. Whoops, I guess I can't do that. I would do 24 over 160. That's the probability of a boy studying art, right?
Mm-hmm.
And then I would do the probability of a boy studying music,
Which is 40.
and then I would add them together. When it's on a table, it makes it easier because you're just going to add those together. But when it says, typically when they say or, I'm willing to accept this or that, that means then you're going to add them. Now, what you've got to be careful with is that you've got to make sure that there's no overlap.
Right.
In this case, there is no overlap between boys studying art or music. They're two separate groups. If some of the boys studied art and music, well, then it gets complicated. And then we have to take that away. But usually when you're adding, you're going to see the word or.
Okay, so when you're adding, it's or.
Yeah.
And when you're multiplying, it's because it's independent.
When it's multiplying, it means that more than one thing is happening, and we've got to multiply them together.
And when it's you would have to find the probability for it fitting into both criteria.
Yes. Well, like I said, in this case, the probability of it being boy and studying music is the number of boys that also study music. They can't just be a boy and they can't be just studying music. They have to be doing both.
Right.
Now, the other time that sometimes we use and is when, what's the probability of this and that? Getting a blue one and a red one. If I draw two marbles, you have to be careful about that because, then I'm doing two separate things. I'm drawing out two marbles. Sometimes they'll use the word and then too.
Do we have to know about the mutual exclusive stuff?
Do you have to? You should know it. How do you know if it's mutually exclusive? Are boys and music mutually exclusive?
I honestly forgot what that means.
That means that you can't happen at the same time.
Oh.
Are there any boys that study music?
Yeah.
Then it's not mutually exclusive.
So it's kind of like independent, right?
You can be a boy and you can study music. If I rolled a dice and I wanted to roll a 3 or a 4, can a 3 be a 4?
No.
They're mutually exclusive. Now, what if I said I wanted to know the probability of rolling a 3 or an odd one?
Well, yeah, because you could do 3.
3, but then I've got 1, 3, and 5. 3 can be odd. You notice how it overlaps? If 3 can be an odd, then they're not mutually exclusive.
So
if I were to say
not
4 and odd would be mutually exclusive because 4 can never be odd. They can't happen at the same time, then they are mutually exclusive. And I guess the easiest thing to do is, do you see this right here? The probability of both things happening, if it's not 0, then they're not mutually exclusive. The probability of rolling a 4 or, oh no, wait, a probability of rolling a 4 and an odd.
well, that wouldn't work.
It's equal to 0. I can
So
roll
if
a
it
4 and I can roll an odd, but I cannot roll a 4 that is odd. If it's mutually exclusive, the probability of both of those things is always going to equal 0. So again, a lot of times these independent problems, you've already had to figure this out. And then they follow up with, are they mutually exclusive? Well, if this number is anything but 0, well, the answer is very simply no.
So if it's equal to 0, if the probability of it being and is if it is equal to 0, then it is mutually exclusive.
Yep.
Okay.
Because that means it can't happen. They can't happen together.
Okay, that makes sense.
I can be a boy and study music at the same time, but I can't be a 4 and a 3 at the same time.
Right.
Any other ones here?
Could you go over number 10?
Number 10?
Yes.
What's that say? What do you got so far?
I made a chart with the possibilities. So
So what are we
did
doing?
one.
We're rolling the dice twice, right?
Yeah.
All right. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and you filled all this in, right?
Yeah.
All right. So then tell me what X is. What's X?
112.
Wait a minute. 2 scores. Total of the 2 scores is 4. So what are the possibilities? 1 and 3.
1
What's
and
another
3,
one?
2 and 2,
And
3 and 1.
those are the only way to get 4. Is that true?
Yeah.
All right. So what's Y?
I'm kind of confused on why. Like,
It says Y is the first score. Oh, okay, I get you. So here's the deal. And then I know this is kind of weird. What we have to do in this case is call one of these first and one of these second. Okay? Now,
Okay.
if this row is first, well then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6 all have a 2 first. Does that make sense?
Yes.
Now, what else? There could possibly be a 5, right?
Yeah.
So that means 5, 1. Whoops, why did I write 4? 5, 1, 5, 2. And again, that's this row, right?
Yes.
5, 3, 5, 4, 5, 5, and 5, 6. Yes?
Yes.
All right, now, what's the probability of X?
112.
Because you did 3 divided by 36, right?
Yes.
Okay. And then What's the probability of y?
1/3.
Because we got what, 12 out of
Yeah.
36? All right. Now what happens when I multiply the probability of x times the probability of y? What do I get?
1/36.
Okay. Now, that's the probability. Okay. So that's this, right?
Yeah.
Now what I got to do is figure out if the probability of x and y is also equal to 1/36. So let's look at it. Basically what it means is I'm looking for any opportunities for the x to also be a y. Now there's not very many x's. Do any of these start with a 2 or a 5?
Yes.
It's the only one, right?
Yeah.
This is the only case where they overlap. So what's the probability of being an x and a y?
1/36.
And it equals what we multiplied together. And so that means that these two guys are independent.
Do we have to write independent? Or
Well, in this case, let's see, it says justify your answer. So, and again, probably you need to do a little bit more than here. You need to say that this is equal to this, so they are independent. Because keep in mind, your answer could be that they're not independent. The point is, if all you do is write all this stuff down and you don't say any words, well, then you're probably not going to get the final point. They're going to look at it, they're going to say, that's awesome, and they're going to think you probably knew what you were doing. But if you notice, if I don't say that they are independent because these two things equal each other, then I really am not I'm not justifying my answer. I've got to say they're independent. That's giving my answer. Then justifying it is saying because this equals this. Does that make sense?
yeah.
And don't get me wrong, after you're busy done doing all that math, you're like, why do I have to write these words? It's worth a point. I mean, many times it's worth maybe 1, maybe 2 points. Maybe in this case, I don't know what the rubric would be, but maybe you're looking for the answer and the justification. So maybe it's worth a couple. Does that make sense?
Yes.
Anything else on here?
Could you also go over 5, number 1?
Yeah, what's number 5 say? No, this is a weird one. All right, so 5, number 1. Notice they're talking about proportion. It's kind of the same thing as being probability, right? All right,
Yes.
so let's do this. Male, female. What's the probability?
For male, it's 3/4, and female, it's 1/4.
All right, now, then the next thing that happens is the curry's hot or it's not. Oh, so I'm going to use hot or not. Hot or not. Yeah?
Yes.
What's the probability of the males thinking it's hot?
3/5.
Which means the females must be 2/5, right? Oh, wait,
I-
not hot must be 2/5, right?
Yes.
What's the females?
4/5.
And then that means what? This has got to be what?
1/5.
1/5. All right. Now it says, find the probability that a chosen student is either female or likes curry hot or is both female and likes curry hot. All right, so let's think about this. This is kind of like what he was asking about, Edwin was asking about the or question, okay? Basically, I want to know the probability of him being female. Well, what's that?
1/4.
Okay, now I'm going to add to that because it's or. What's the probability of, again, anybody liking it hot?
3/4 times 3/5 plus 1/4 times 4/5.
All right, so this is probability that anybody likes it hot. Yes?
Yes.
All right, now, here's the thing. Both female and like it hot. I've already counted every female. Does that make sense?
Yes.
I've already counted every person that likes it hot. So if I add this to it, I'm duplicating. Does that make sense?
Yeah.
In fact, if you take a look at this is the boys liking it hot or the males? Which one's males? 3/4? This is the males and this is the females. Do you agree?
Yes.
Now, I've counted all the females here. So do I really want to count the females that like it hot?
No.
No. Does that make sense?
Yeah.
I don't want to do this, and I don't know. I think they're just throwing this in there to confuse you. Because, like I said, whenever you get an or question, you still only want to count things once. You're either a female, you like it hot, and they're both, like I said, I've already counted the females. I've already counted the people that like it hot. In fact, when we've written this already down, I've already counted females twice because these females liked it hot. So really all I need to do is this. And that'll give me the answer.
Could you also do like 1 minus the males who don't like it hot?
One.
Because like the question's stating everything except them.
Find the probability that the student is either female, likes it hot, or females that don't like it hot. Well, so then you would need the opposite of this is boys, males, right?
Yeah.
And they don't like it hot, right?
Yes.
Yeah, I think you could, but it's going to be the same thing. You know what I'm saying? It's not going to be any less work. But yeah, my guess is you should get the same answer if you do that. Anything else?
I have a quick question.
Yeah, what's that?
Okay, so it's on number 9.
Yeah.
So I had a question like on the tree benches. So like why wouldn't like we create another tree branch for this diagram? Cause I thought it would be like more than 2 situations. Cause like you're
Well, how many balls we taking out?
1.
And then a second one.
Mhm.
This is the first ball, and this is the second one. What are my 2 possibilities?
You either get a red or a blue ball.
And then, now what's happened? They add a yellow ball in there, right?
Yeah.
So now, what are my possibilities?
You either get red, yellow, or blue.
Sorry, I already started the B. Oops. That's true, right?
Mm-hmm.
The trick with this is we got to figure out our probabilities. How many red ones are there in the beginning?
3 out of 8.
How many blue ones are there?
5 out of 8.
That makes sense. Now, how many balls have been added?
Oh.
a yellow ball, one yellow ball is put into the box, right?
Mm-hmm.
All right, now, if I go along this branch, I've taken out one red. So how many reds are left?
2.
But now there isn't 7 marbles because I added 1. Does that make sense?
Yeah.
Now, how many blue balls? There's still 5 blue balls, right?
Mm-hmm.
Out of 8. And how many yellows are there?
1 out of 8.
Now let's come along here. If the first one moved is a blue, well, then there are still 3 red ones.
Mm-hmm.
But because I added 1, there's 8, not 7.
Mm-hmm.
And if I took out a blue one, there's only 4 left out of 8.
Mm-hmm.
And if I took out a blue one, that's not going to affect the yellow one, and I get that.
All right.
Does that make sense? We
Yeah.
only removed 2 balls. Now, what's weird about this, and this is kind of what I'm talking about, we made a change between these 2 branches, and that's
Mhm.
perfectly okay.
Yeah.
The fact that we go from a 2 splits to now all of a sudden there's 3 possibilities, well, that's
Mhm.
okay.
All right. Yeah.
And again, notice this one. Find the probability the first ball is red, given the second one is blue. So I need to find the probability of both. That means the probability of red and then blue, right?
Yeah.
And then I got to divide by the probability of blue. And where is there that I can find red and then blue?
In the top
Red
section.
and then blue, right?
Yeah.
Those 2 multiplied together is going to give me a red one and a blue one in order, right?
Mhm.
And see, in this case, the order is important because they're very specific. The first one has to be red and the second one has to be blue. Now I'm going to divide by all the possibilities for being blue, being the second one. Well, again, that's going to be this again. But how else can I get a blue?
You get 2 balls are blue. So
Right.
and the one. Yeah.
Does that make sense?
Yeah, that makes sense.
But you got to be very, very noticing this kind of thing. They love to ask these conditional probability questions.
Yeah. I think like what confuses that like there's more than one thing going on, So
Yeah,
assume that's the
exactly.
situation.
Well, they also like to mess around with the tree diagram sometimes and make them a little bit weird.
Yeah.
And all you got to do is just think about it. Instead of thinking it has to be something particular, okay, these are the only 2 choices. But after the first ball is drawn out, well, now there are 3 choices. And I didn't put it back, so that's the problem. That affects the probabilities. How we doing? Is that good?
Yeah.
All right. Anything else?
Are you gonna post an answer key tomorrow? Or do you plan on posting an answer key?
I can.
Yeah.
You want me to do
That'll
that?
be. Yeah.
Yeah, I can do that. I just got to take off the work. But yeah, I can post the answers.
All right. Thank you.
Sure. Kayla, how we doing? You got anything else?
I'm good.
All right, awesome. All right, I'm gonna let you guys get out of here then. Oh, is there another one?
Yeah, me.
What's that?
I was looking at number 8,
All right, 8,
and
yeah.
I'm confused because like the percentages, like it says, when Jake attempts the crossword puzzle, the probability that he will complete it on Monday is 0.8, and that he will complete it on Tuesday is 0.9 if he completed it on the previous day, and 0.6 if he did not complete it on the previous day.
All right, so let's try writing this down. What's the probability that he completes it and then he completes it?
Probability that he completes. 0.8 times 0.9.
Okay? Now, what's the probability that he completes it and then he does not complete it?
0.8 times 0.6.
How'd you get 0.6? If this is a probability,
Wait, no,
what's,
0.1, my bad. I was reading it wrong.
right?
Yeah.
Now, what about this? What's the probability of not completing it and then completing it?
Not completing it. 0.2
Times what?
0.9.
If he completed it on the previous day,
You said did not complete and did complete. Is that what you said?
yeah, well, yeah, did not complete and then did complete.
Oh, did not complete.
The probability to complete the puzzle on Monday is 0.8. The probability to complete it on Tuesday is 0.9. If he completed it the previous day, and 0.6 if he did not.
So 0.8 and 0.2 and 0.6.
Right.
Okay.
All right. Now, do you see that how we've kind of pretty much labeled all the possibilities here? Either he does it both, or he does it once and doesn't. I guess the only one we didn't do is he doesn't ever do it, right?
Yeah, but we need at least one, right?
What's that?
Because it says find the probability that he completes it at least once.
All right. So, yeah, exactly. So that's why we're not considering not.
Oh, so once we multiply, we would
Because in
add
all these situations, yeah, exactly. This is going to give you a number. This is going to give you a number. This is going to be a number. This meets the criteria. This meets the criteria, and this meets the criteria. Then I take all of those and add them up to get the probabilities. Think of it like this. I would be happy if he did it on both days, or if he did it the first day and not the second, or if he didn't do it the second or the first and did do it this. And again, you notice when I say or, then I add them. I'm happy with this, or with this, or with this. Now in this
because
case,
they're all different possibilities, right?
exactly, but they all meet the criteria. In this one, I have to do it and then do it. They both have to happen in order to meet the criteria. I need to do it and then do it again, and that's why I multiply. I got to do it and then not do it. But in order to meet the criteria, I've got to do both of these things. So it's this and that, and that's when I multiply. Does that make sense?
Yeah, you wouldn't multiply because like it doesn't want all three of them together.
No.
It's just at least one of them.
So what happens is when you're finding probabilities, sometimes you can find more than one situation that meets your criteria. And if you do, you just find them and then add them up. It's kind of like the tree. When you do this tree, if I asked you the probability of getting a blue one on the second pull, well, that happened here and it happened here. I would multiply this times this and this times that, and then I would add them together. Because in both cases, the second one was a blue. There was more than one way for me to be happy. Cool?
You multiply because there was okay.
Because these two things have to happen. Both of them have to happen in order to meet the criteria. This and that. But he doesn't need to do both of them and then both one and not the other. He doesn't have to do both of these things. Does that make sense?
Yeah, he only needs one.
He only needs one. So I'm happy with this or this or this. But here, this has to happen, this has to happen, it's and so I multiply. All right, well, I appreciate you guys coming. Hope this helped. I'm going to get out of here. Have an awesome day. Okay?
Thank you. You
Thank,
too.
thank you, Mr. Cross.
All right.
Thank you, Mr. Cross.
Have a good one now.
Mr. Cross,
Yeah.
for number 5, why did you take out the 1/4 times 4/5?
For number 5. Why did I take out what?
For number 5 on part, like the first part, you know how you wrote down possibility of F plus possibility of H? Why did you cross that part out? I didn't understand what you meant by that.
So think about this. This is the probability of being a female, right?
Yeah, 1/4.
This is the probability of liking it hot. Anybody liking it hot. That includes females, right?
Yeah.
Okay. So the reason I took them out is because I counted every female with this probability right here.
Mm-hmm.
I only want to count the females once. So I'm not going to count the females that like it hot. I'm just going to count the males that like it hot.
Because it doesn't want both.
Because, again, you see how it's an or situation? Or. But the thing is, in this case, you can be in more than one group. And whenever that happens, you have to make sure that you only count things once.
So you would do, so for the first part,
So
You
think
would-
about it. I want females and females that like it hot. But if I count every female, I've got all of them. Right?
right. You
Then I
wouldn't
want
do it-
everybody that everybody likes it hot. Well, I'm not going to count the females because I already counted them.
So you would just count the ones with males,
The males, exactly.
and that would give you 7 tens. Right.
When you put them together, yeah, 7/10.
And for the second part, we would just do the same thing where it's like the probability of male times the probability of the student
Probability
liking something
of-
hot is equal to both male and hot to show that it's independent. Is that what we would do for the second part?
So I'm going to find the probability of being male, which is what?
3/4.
I'm going to find the probability of anybody liking it hot. What's that? Do you remember? That was
3/4
those two things multiplied together.
times 3/5. Would it be plus the other one?
Yeah, these two added together. This times this and this times that. Those are all people that like it hot, right?
And it has to equal m and then the
Well, what do you get when you do that?
which one? The h?
The hot, yeah.
Let me see. Because you would include both, right? So you do 3/4
Yep.
times 3/5
Plus.
plus 1/4 times 4/5.
Yep.
13/20.
All
And
right.
that'd be
I'm
3/4.
going to multiply those together and I'm going to get a number. All right. Now I need to compare that to the probability of being male and liking it hot, which that is just going to be
3/4 times 3/5.
Yeah. If I multiply this times this, if this number is the same thing as this number, then they're independent. And if it's not, then they're not.
It's not.
All right. Is that cool?
So it's not, since it's not equal, I would say
It's not independent.
independent, and I would show that they're not equal, right?
Right.
Okay. So is the quiz on Thursday on this? So like,
Yeah,
the
this, I haven't made it yet, so I don't know. But yeah, it'll be this kind of stuff.
okay.
Cool.
Awesome. Thank you so much, Mr. Cross.
Have a good one now.
Yeah, you too.